afternoon in the Philippines. Greetings to all of you on the occasion of this last session of AWS9, which we are holding in the midst of this health crisis. I'm referring to the COVID pandemic, which has really affected not just the human health, but also the health of nature, and in particular, the health of our wetlands, which are our main concern as proponents of changes and the solutions to new challenges to wetlands management. I should make mention also to you the fact that this health crisis brought to the fore also not just human health, but the the matter of law as a branch of health law, as a branch of environmental law. And we are all aware of the importance of law in regard to this management of effective management of our wetlands. Now, this last session is on policy issues, and we are well aware that a policy is a course of action among alternatives to give or in making final decisions for the effective management of wetlands. And in this connection, what easily comes to mind are the original wetlands policies based on our Ramsar Convention, which are wise use and also the awareness of the services of wetlands to people. Now, this last presentation has three papers, and one is by Mr. N. Tao, which is about a topic which is very much mentioned in the long title of our Ramsar Convention. As you are well aware, our Ramsar Convention is celebrating its 50th year this year. And what I'm driving at is the fact that the title includes the matter of waterfowls as inhabitants of wetlands. And waterfowls are mentioned, as you will notice, in that very long title of this Ramsar Convention. Actually, our presenter is Mr. N. Tao Wu, and it is also a group presentation, but he is supposed to be presenter, but I think he's encountering some difficulties. And so we'll have as our first presenter Miss Ridit Saluja, and the title of her presentation is on Index for Indian Wetlands. Hers is a group-produced paper, and along with Ms. Saluja, the paper was done by Harsh Ganapati and Mr. Ritesh Kumar. So you have the floor now, Ms. Saluja.
Thank you
so much. Thank you, Chair, for the introduction. So I'm here today to present our small research work that we undertook to develop a trend index for Indian wetlands. And along with me, Dr. Ritesh Kumar, the Director of Wetlands International, and a colleague, Harsh Ganapati. We have worked together on preparing this research. So by putting in context, I want to first say that wetlands inventory, has led to a lot of, it has progressed over the years with the kind of data that is available now and the progress in the satellite imagery that is available for analysis or assessments have improved, and the approaches have increased in. I'll just increase the volume. Am I audible now? Sorry for that hiccup. A lot of inventory approaches have been taken up worldwide, including the global wetlands extent mapping, and also the regional assessments, and also country level inventories have been undertaken. But in certain areas, there's still a challenge in assessing the extent of wetlands and at which rate the wetlands are being lost and degraded. For this, to actually look at this aspect, inventories have been carried out over the years using two approaches. One is a top-down approach where a satellite data is used to map the wetland distribution in the entire countries or regions, or even at the global level, where the scales of assessments vary with the region that is being analyzed. Also, there are another set of inventory approaches which are known as the bottoms-up approaches, where we are more reliant on the ground data, such as the citizen science programs, which includes the most famous international water bird census, and also the Asian water bird census, which is being led by our office here in South Asia. So here, what we are trying to do is we are trying to collect the field data, the field information about the wetlands, and then we are then working all the way up to the national up to a national index or a national measurement of wetlands distribution within the country. And similar attempts have also been made by other countries such as Ecuador, and even the most popular MedWet database is also utilizing a mixed approach where there is an equal participation of citizens, and there is equal contribution from the science angle, which includes the remote sensing and GIS tools. Moving on, I would like to also make a note that India also has prepared its second wetland atlas, which was a top-down approach where we relied on remote sensing data, and this was published in the year 2011. But still, with respect to India, this inventory is giving the wetlands extent, but it is not telling us where and to what extent the wetlands have been lost, or where are the areas within the Indian subcontinent which have lost the wetlands. So in this research, what we tried to do is we tried to develop a wetlands trend index, which acts as an indicator of the status and trends of wetlands in the wetlands ecosystems in the country. So this approach actually helps in monitoring the progress towards various policy goals and targets. It is also has been used before by several authors such as Dixon and Dara, which was a further refinement of the index which was developed by Dixon. Here, what we've achieved, was a global wet index, and the regional indices were developed for different regions, including Latin America, Asia, Asia Pacific region. So here, the major outcomes were that rapid wetland loss has been reported from Latin American region. So a similar attempt has been made for the Indian subcontinent in our research as well. So this data that the trend index that we are coming up can also be utilized for national level reporting, and also as a response to our regional and international commitments. So how is that we are approaching this problem? So for developing a wetland trend index for India, what we relied on was a living planet index, which you must be aware that has been previously used to actually identify on what rate global species have been lost, and this has been done for a cumulative assessment for all the species, all the biodiversity world over, and also sub indices have been generated for different regions and also for freshwater species. So this is, this approach comes handy when our input data is inconsistent and non-uniform. It is non-uniformly distributed in the region of analysis, which in our case was India. And also LPI recompenses for this patchy data distribution by assigning equal weights to wetlands across different biogeographic zones of India, which we have 10 that we have analyzed. And this is then aggregated into a national level index. And we have also attempted to actually, separately develop a wet index or a trend index for both the natural and human-made wetlands in India. So the trend index that we have developed is equivalent in operations as the LPI, which was the unit of assessment as previously used in developing a global wet index, and also the LPI, which is used as a reporting index by WWF. So what was the exact method? How is that we utilize this LPI approach to develop a wetlands trend index for India? So step one was that we collected different time series data from the time period of 1980 to 2015, and the total data set accounted for around 202 time series, and it was derived from different data sources, around 120 data sources. These were gray literatures, these were research papers, assessment reports, and NGO reports on different wetlands change from either basins or city level experiments or city level studies, individual wetland site level studies. So we have collected the data from all the resources which were available. Then these time series data were codified and entered into a database system where each time series was assigned into a BGZ. So within India, based on the classification of the ENVIS system, which is the Environment Information System in India, we have 10 different biogeographic zones. As you can see here, we have Trans-Himalayas, Himalayas, Northeast, Desert, Western Ghats, Gangetic Plains, Deccan Peninsula, semi-arid region, islands and coasts. And this map below shows the distribution of these 202 data points all across India. And you can see that the data points are not homogeneously distributed. So there is a inherent skewness or under or over representation of certain biogeographic zones in the index that we are trying to develop. And also the data scale is varying. For some region, we have the data with respect to the site. In certain areas, we have it with respect to district, and so on and so forth. So what we tried to do after codification and data entry, this entire data was bifurcated into different sub-indices. So the wetland data points would, distinguished into either natural wetlands or human-made wetlands, and also with respect to the different biogeographic zones. And this was then, analysis was further taken up in an R package called RRC-EA, following the methodology which is prescribed in Low et al. 2005. And the last step was to accumulate or to aggregate all these sub-indices into a trend index for Indian wetlands. So what does the result show? As you can see, for a period of, starting from 1980 till 2015, there has been an increase in wetlands area within India. But now this information can be a little misleading. So we need to see what is the actual picture behind this. So this graph is reporting an increase of around 10 to 12% in wetlands extent in India. But let's look at the other picture. The aggregated wetland index was developed, by combining the natural and human-made wetlands extent. So here what we are seeing is what has been the increase in human-made wetlands, and the human-made wetlands are shown in the blue line, and also the natural wetlands are shown in the green line. So here we can see that there has been a tremendous increase in the extent of human-made wetlands within India, and also the natural wetlands are following, they are having a negative slope, so they are constantly decreasing in extent all over India. So the decrease in extent of natural wetlands is around 18%, whereas the increase in the extent of human-made wetlands is around 45% across all biogeographic regions in India. Moving on, when we further analyzed how the wetland extent has changed over this period of around 3 decades, we can see that the extent of natural wetlands within Trans-Himalayas, Trans-Himalayan biogeographic zone, there has been an increase of around 50–55% in Trans-Himalayas, and this is largely attributed to the glacial melt, which has increased due to the changing climatic conditions, the increased temperature and altered precipitation patterns in this biogeographic region. On the contrary, we can see that there is a marked or almost equivalent decrease in wetland extent within the Gangetic Plains over the same period. Similarly, we can see that the wetlands extent has also declined in other biogeographic regions such as Northeast, Himalayas, deserts, and coasts. Here we are representing, the results from only 7 biogeographic zones because the data from other 3 was a little underrepresented because they had very small sample size to begin with. Now, coming on to the extent of man-made wetlands, here we can see that with respect to human-made wetlands, there has been a increase in almost all the biogeographic regions, and the increase has been maximum in desert and along with the semi-arid region. But this the confidence interval of 95% is showing that the increase has been maximum in coast, followed by semi-arid and desert region, whereas the Deccan Peninsula, which is where the human-made wetlands are largely tanks and ponds here, there has been a decrease in their distribution, and this is largely because of their poor maintenance and their conversion to some other land use in these areas. Now, once we have established where all these wetland loss and degradation is taking place through the wetland trend index, the another point of discussion, which is very important in implementing the wise use principle, as per the Ramsar's, as per the Ramsar, India's commitment to Ramsar Convention. What we tried to do was we tried to understand what are the major drivers of these changes in wetland extent for both the natural wetlands as well as the human-made wetlands. But for this presentation, I'm only restricting myself to identifying the direct drivers which are impacting the distribution or which are impacting wetlands, the natural wetlands in India. So here what we can see is we had identified drivers for all 10 biogeographic zones, and the drivers were classified into 4 different types: the physical regime change, extraction, introduction, structural modification, following the global wetland outlook method. Here also we have 4 different drivers within physical regime change and 3 drivers within extraction, 4 under introduction, and 4 under structural modification. So this analysis has shown that there are multiple drivers which are leading to extensive changes within different biogeographic regions. For example, for Deccan Peninsula, you can see that majority of the drivers, including water frequency, water quantity changes, sediment regime changes, extraction of biota, increased discharge or introduction of nutrients within wetlands, invasive species, the discharge of or the solid waste disposal within the wetlands, the drainage of wetlands and conversion are the major drivers of change within for the natural wetlands of Deccan Peninsula. And similar has been the case for coasts, where water quantity, sediment, and salinity changes along with nutrients are driving major changes in this particular biogeographic zone. And these, the impacts which we have rated as high, medium, and low here are also significant at 95% confidence interval for coastal wetlands. Also, with respect to the Indo-Gangetic plain wetlands, you can see that here the highest impact is due to nutrients, and this value is also significant at 95% confidence interval. But this data, as of now, has been a qualitative assessment. This has been a qualitative assessment where we have simply, coded the data based on our initial database, which was developed and from the same resources as from which we had derived the trend data. Now, in addition to the direct drivers of change, we need to understand what are the broader scale indirect drivers of change which are influencing the direct drivers and causing a change or leading to a change in the ecological character of wetlands. So here we see, or this analysis has shown that climate change has been a major indirect driver which is underpinning the direct drivers of adverse change across several biogeographic regions. So here you can see that for almost for around 3 of the biogeographic regions, the impact of localized climate change is high, and for 3, it is low. So we can say that, and in addition to this, the coastal wetlands are also affected by a large number of indirect drivers of change, which include the establishment of water energy structures, which is leading to an obstructed flow. And this was actually reflected in when we were analyzing the direct drivers of change, that it is also impacting the physical regime change within this biogeographic region. Also, tourism development over the past few decades in India is also a major driver of change, major indirect driver of change, which is leading to other drivers, which is actually underpinning the direct drivers of change, which include solid waste disposal or sedimentation or conversion to other tourism infrastructure or urbanization in these areas. And this impact has been highest in Himalayas and Trans-Himalayan region. Now, what are the key conclusions? As we were able to see through our results, that natural wetlands are lost at a rapid rate within the Indian subcontinent. The drivers are differentiated across different biogeographic zones. Different, drivers are, more influential in certain biogeographic zones, whereas other biogeographic zones have different set of drivers which are impacting the ecological character of wetlands. Also, peninsular India's wetlands as well as the coastal wetlands are the most vulnerable to change and are impacted by a myriad, are impacted by a lot of different drivers of change. Also, from a broader perspective, or the indirect drivers which are impacting these direct drivers of change are tourism and climate change. But with respect to the results that we are presenting here, there are further refinements which can be made in, which can contribute to a further, improvement in our results. It could be made through, number one, increased representativeness from different biogeographic zones. As I had shown in the initial graph, that the biogeographic regions, including islands, the Western Ghats, are very, very underrepresented in this particular trend index. Also, wet index can be developed for different wetland types. For example, inland versus coastal, lakes versus mangroves, or we can also have it for lakes and ponds. So that kind of additional analysis can be done at a later stage. And also the drivers data, which currently has been analyzed with respect to its significance only, we can also use that to establish regression analysis and draw meaningful links between the drivers of adverse change and the impact on wetlands in different biogeographic regions. Thank you very much for giving me the opportunity to present our work to the participants of AWS today. Thank you.
Thank you very much. Thank you very much, Ms. Aluja, for your very interesting presentation. I have to confess that the reason why I've always maintained my participation in all of this AWS, even though my field is law, is because I want to be educated also on the technical aspect of wetlands management. I am amazed that at the number of papers in this AWS9, which were presented, that revolves around the information techniques, what we call information trends, what you call drivers of deterioration and degradation, that is very, very important in arriving at a policy on the use of these various new techniques. Now, Ms. Aluja, do you have information about the use of this trend index in some other countries of South Asia in particular?
As far as my knowledge goes, till now it has not been developed for any specific country. The trend index so far has been developed on a global scale. as I just reported that it has been developed by Dixon et al. So that was at a global scale, and it had information with respect to certain regions. But country-specific wetland trend index has not been developed so far. So our initiative here would be one of the first on that aspect. Yeah.
Thank you. Thank you very much. And keep on. Now, we have a question. No other question. So again, Ms. Saluja, thank you very, very much for your paper presentation. Now we go to a paper on regional collaboration for wise use of wetlands. This is a paper that was done by Dr. Ritesh Kumar, Director, Wetlands International South Asia. Dr. Kumar, please.
Thank you so much, Ambassador Talent. It's a pleasure to meet you virtually. And thank you so much for this opportunity to present this idea of regional collaboration. This also builds on the work that Wetlands International South Asia has been doing with Ramsar Regional Center on East Asia to move up to a basis of exchange and learning, co-learning and shared learning within South Asia region. I'll share my screen. Okay.
Yes.
When we look at wetlands of South Asia, this is a cluster of most rapidly growing economies. Yet they are also one of the most drying economies. Water is increasingly becoming scarce. On one hand, we have the most dense surface irrigation structures in the world, yet it is also the global groundwater capital. In fact, over 70% of global groundwater use is done in South Asia region alone. And on one side, we have the civilizations which grew around water and wetlands, yet we are also seeing that South Asia is a region of rapid decline, which my colleague Riddhi Saluja showed through her work on Indian wetlands, but these storylines are very similar for other areas as well. Now, why do we call for a regional collaboration? The very fact that we are monsoon driven, so we share the same climate and biogeographic settings. On the west, we have the desert. To the east, wherein we share the realm of moist, subtropical moist broadleaf forest. So there is quite a bit of biogeographic homogeneity, although the regional differences are there. But we also share a lot of species, whether it be the black-necked crane, which is shared between India, Bhutan, and China, whether it be the iconic Sundarbans tiger, which does not recognize any political boundary and is found in India as well as in Bangladesh, or the Ayurvedi dolphin, which ranges between Chilika Lake in Odisha to being found in India, Bangladesh, and Myanmar. So we share these wetlands apart from the political delineation of countries. The species actually survive on the network of healthy wetlands, and not to mention over 800 waterbird species which use South Asian wetlands for their completing their migration sojourn. We also have a shared water history. The irrigation, when you look at the irrigation infrastructure development in the region, which developed in the colonial regime, it's a similar water resources development process that was adopted. Certain countries have advanced in terms of water storages, but the surface irrigation economy that has emerged in South Asia is one of the most unique one. Yet, as I said, the technology of smallholder groundwater pumps means that there are a couple of million individual smallholder pumps that are governing groundwater use, resulting in stark declines, especially in areas which are the food producing bowls in Pakistan and India. So what is happening to this world, to these wetlands? And you will see a complex set of drivers. But what I want to insist that addressing this requires some regional action. Major deltas, if you look at Sindh Delta or the Sundarban Delta or the Ayurvedi Delta, they are all sinking. But since the river regimes are all connected, it is not possible to control delta sinking just by acting within our national boundaries unless we cooperate on water management regionally. Similarly, if you look at the Bay of Bengal, it is fast emerging as a dead zone, but this is beyond the reach of any single country to take meaningful action on controlling this dead zone, given the kind of microplastics, nutrients that are drained into the bay, which is a shared regional property rather than being a national one. And interestingly, Ramsar Convention gives us the binding clue. Except Maldives, most of the countries, all the countries are members of Ramsar Convention, and that is what gives us the basis of working through using convention as the platform and Ramsar Regional Center East Asia as a mechanism wherein the countries can come together and discuss the challenges. I read through the national reports which we submit to the COP, the Conference of Contracting Parties, and it is not surprising when you talk of the knowledge gaps, capacity development gaps. They're shared. You start identifying a pattern which is emerging, and on basis of this we have identified opportunities for regional collaboration. For example, inventory approaches. India has a very advanced satellite inventory approaches. We have a very good example of site level inventory approach in Sri Lanka, and we have in Myanmar a directory being developed, or in Bhutan we have an excellent high altitude wetlands inventory. If we bring these skills together, we can assist each other in developing a good regional wetlands baseline. Right now we are speaking or using different data sets and approaches, but if we work together, we share how we could inventory wetlands, the tools, technologies, remote sensing. We could actually help the national governments in developing robust inventory systems and their review. Embedding wetlands in urban planning. South Asia is also it has several mega cities, and Colombo in Sri Lanka showed a wonderful example of how a city can become sensitive to wetlands and restore wetlands. The picture on the top is the picture of Sri Lankan Parliament, which was under water due to floods. For the basic reason, it was built on a wetland. But from there, Sri Lanka, Colombo city has come up to a situation where it is accredited as a wetland city, and they have implemented wonderful wetland restoration programs. Now, this is something where cities like Dhaka, East Calcutta wetlands, Myanmar, all of these cities can look up to these role models and see how Colombian the experiences of Sri Lankan government in saving wetlands of Colombo could be applied to situations like in Dhaka. Asia, and South Asia in particular, has a long history of traditional livelihoods being connected to the wetlands, and Bangladesh in its Tangwar Haur community program has shown how communities could be at the forefront of managing wetlands. Now, such lessons can be extremely useful for small wetlands which dot the entire South Asian landscape. Governance in India, the Chilika Development Authority has shown a role model and how you can connect political leadership with wetlands and ensure a good restoration story. And this is a model which has emerged from South Asia region and can be tried out, can be learned in several parts of South Asia. Agriculture is the hub of South Asia. It is the lifeline, and you will see most of our wetlands sustain some form of agriculture, be it the choosing system in Bhutan, the Apatani rice fish system in Arunachal Pradesh, the tank irrigation systems in Sri Lanka, or Pokali, Kerala. Now, the beauty of these systems is they don't destroy wetlands. These farming systems are closely aligned with the way wetlands behave. They don't modify wetlands, and possibly if we cross learn, we can most of the country reports say that agriculture is the biggest driver of wetland degradation, but these models show how wetlands and agriculture could coexist by sustaining the environment as well as providing for food security, provided we learn from these systems. Similarly, on policy domains, now we have taken Pakistan, Myanmar, we have draft policies. India has a regulation and a water policy, and Nepal and Sri Lanka have well defined policy, wetland policies. Now, can we learn from what was the process of policy making and how could we monitor policy implementation? There are tremendous opportunities in the region. Ecotourism now, given there are, in Bharatpur in India, there is a role model on how reviving a wetland could be a very strong impetus to nature friendly tourism. If you look at Myanmar, I was at Myonjai, similar approaches are being tried. If we bring these two learnings from these two cases together, we have a tremendous opportunity of helping each other out on what strategies are practicable and feasible. Similarly, approaches for integrated management planning or the health card system for wetland monitoring in India, which has now become a national program. Over 1,000 wetlands are being monitored through a grading system. We assign, as a child gets school grade, wetlands are being given school grades. These grading systems could be taken up in all wetlands, and they could be quick way to communicate ecological health to different different situations. Water remains a formidable challenge. As South Asian economies are centrally linked to water, the way water is allocated and used for various human and ecological uses is a major challenge that wetland managers can face. Our learnings in Sri Lanka, India, in Loktak can be very useful signposts on how we could avert these trade-offs, or we could negotiate these trade-offs casually. Most of the South Asian countries are endowed with very good mangrove cover. In fact, the mangroves of the Sindh Delta, mangroves of the Indian Sundarbans, mangroves of Irrawaddy Delta, these are the largest mangroves, intact mangrove systems in the entire tropics. We could easily share our learnings from each other and apply this to areas where there is increasing stress. For example, it is projected that Irrawaddy Delta mangroves could be gone because of increasing water regulation upstream. So there are learnings that India and Pakistan can provide to Myanmar on this technical exchange platform. So this idea of regional collaboration was discussed with Ramsar Regional Center East Asia, and this is a photograph of the executive director of Ramsar Regional Center and the president of Wetlands International South Asia entering into a formal MOU to collectively work to build capacity of wetlands managers in South Asia. We held the first regional meeting, which was hosted by Sri Lankan government at International Water Management Institute in Colombo, and it was identified that such an idea is actually very feasible, and it can actually support implementation of Ramsar Convention by providing a basis of regional exchange, monitoring of Ramsar sites, collation of case studies and best practices, development of roster of wetland experts, and focusing on capacity development. The participants of the first workshop recommended that a follow-up workshop focused on water be taken up by Wetlands International and Ramsar Regional Center East Asia, and we are proceeding to do this in the third quarter. So with this, the call is that we do, all of South Asian countries are taking tremendous measures to ensure wetland wise use, conserve wetlands, but we are also challenged by a unique socio-political setup. Communities are largely linked to the way wetlands behave, so models for wetlands conservation have to evolve from learnings of each other rather than being transported from an external world wherein the socio-political situation or geopolitical situations are very different. And with Ramsar Regional Center East Asia, we have a very wonderful platform wherein the countries can come together, cross-learn from each other, and improve the health of the wetlands. Thank you so much, Chair. This was all that I wanted to share in this presentation. Thank you so much.
For your excellent discourse on. Thank you very much, Dr. Ritesh Kumar, for your excellent discourse on the regional platform concept, which could lead really to selection of new policies to guide our decision makers for more effective um, management of wetlands. I was sort of moved by your pictures for the reason that maybe 2,000 years ago, I did environmental law connected works in the countries of South Asia also. And I was very surprised in particular that my first work on environmental law was in Sri Lanka. And after that, I was able to go back and forth. And I did not realize that that parliament is built on a wetland. So I have to relay to our people, to our audience, that our AWS, no, our RCJ, which is holding this AWS from time to time, had always been more or less about the ASEAN countries, and I'm very happy that South Asia had come into the picture. Before this AWS9, we had started on, I would say, a successful project which is still ongoing, and that is the Bay of Bengal project. And we have long association with the Chilica Lake Development Authority by Dr. Ajit Patnaik. And I hope that there will be more association with young people of South Asia on effective wetlands management, especially at this point in time that it seems we are into a really changed world. Now, do we have some other comments and questions?
Chair, if you kindly permit, there is a question from Kim to the panelist on how can other scholars assist with the regional work.
Okay, please,
So,
please.
yes, the scholarship is essential. So, the basis of regional is a robust regional collaboration is on good science and technical exchange. And I think through the mechanism of Ramsar Regional Center East Asia and Wetlands International, we will work to create a space to bring scholars working on wetland issues in diverse disciplines. One of the mandates that the governments gave us was to create a roster of experts. And beyond, I think, roster of experts, we should also map out who are the people working on wetlands on different aspects and ensure that your science is provided to people who actually need this science, with this platform being the bridge between the users and the providers of science. So we'll be more than happy, and let's continue this dialogue even post the symposium. Thank you so much for this nice question.
To wrap up, it's just a pity that we were not able to have the presenter from China, which is about the wintering geese. As I told you, it was very nice of him to write about waterfowls because of the emphasis of the Ramsar Convention on waterfowls as inhabitants of wetlands. And, maybe for some of those of you who are not aware, this 1971 Ramsar Convention came into being at the same time when the first international conference on environmental protection was being held in Stockholm. So the Stockholm Conference is celebrating its 50th year also. And the Ramsar Convention started as a very, very simple convention that we who somehow work about this convention did not expect that it will gain so much prominence. As a matter of fact, this health crisis brought together, or even before the health crisis, four conventions were brought to the fore. I'm referring to uh, Convention on Biological Diversity, Convention on uh, CITES, uh, um, trade, trade of endangered species of plants and animals, and also the Migratory Birds Convention and this Ramsar Convention. They are like quadruplets, twins, in the sense that the fact that they are now together. I say together because before there was no intercourse or interconnection among the secretariats of these four conventions, and now they are in very, very close association. That the conclusion is this climate change uh, issue, uh, which is now accepted as a twin to the health crisis that we have, will, I would say, forever be treated as such because one cannot exist without the other, in the sense that climate change had already climate change had already reached not just human health, but also the health of nature, the health of wetlands ecosystems in particular. So no way for wetlands not to be included in all of these developments brought about by this health crisis or health pandemic. Now, our policies or the policy issues, I would say, as written in our program, is a very good place or sort of the policy issues would be very, very good for countries and regional countries and individual countries to approach, considering our experiences in this health crisis. I noticed that many of the presentations revolve around the effects of the health crisis on wetlands in such a way that what emerged, among others, was nature-based solutions to some of these wetlands problems. Very interesting, very, very interesting. But my wish and my hope will be the experience that we have so far gathered will be will be will go on uh, considering the changed world as I describe it that we are into now. Here are some other questions. Well, I think this is addressed to Dr. Kumar. One is how can other scholars assist with the regional work? Another question from Yoshi Kobayashi to the two panelists, Ms. Aluja and Dr. Kumar, is if any central deposit of all information regarding regional collaboration or information is managed by each country, may, is there any central deposit of information regarding regional collaboration or information? And then, yeah, please, Dr. Kumar.
Thank you so much, sir. I did answer the question raised on the scholars. On the question on central repository, yes, indeed, information on different aspects of regional collaboration is available by agencies like Integrated Center for Integrated Mountain Development, or South Asian Regional Cooperation Hub, or ADB and World Bank. But wetlands do not find a conspicuous mention. This is still a gap area. Wetlands International is striving to provide a harmonious exchange of information between the countries, but this is something that this platform also strives to achieve, to ensure that there is good sharing of information, and a repository of wetland work is maintained for benefit of everyone. Thank you, sir.
So again, thank you very much. And that ends our session 8 on policy issues. Thank you very much. Thank you.